Hello, everyone, and welcome back. We have so much exciting content to continue discussing today, so I'm going to dive right back into things. I'd like to start by inviting our Star Trek panelists to go ahead and turn on their cameras and to join me here, and then we'll be able to dive in to our content. I see I have someone else with me here on the bridge. Welcome. Welcome, Jennifer. So we're going to go ahead and get started here. By going around, I'll have each of our panelists introduce themselves. I'd like you to please say your name, what field you're working in. So tell us a little bit about yourself and how it connects to the science of Star Trek. So what topic you're most interested in discussing with us today. And last but not least, your favorite character. So starting off here, I'm going to go to Jennifer Johnson from Ohio State's Astronomy Department. Oh, sorry, you're muted at the moment.
I'm Jennifer Johnson. I'm a professor here in the Astronomy Department, and I care most about the exploration of space, and I'm very jealous that in Star Trek they get to go up and examine things up close and personal. I have to infer everything from a really, really, really far distance away. And my favorite character, I have many of them, but I think there's a certain joy I get in watching Captain Janeway be the captain.
Amazing. Thank you so much. Next up, we have Professor John Horak.
Hi, I'm dressed as John Horak today. I hold the Neil Armstrong Chair in Aerospace here at Ohio State. I'm in the College of Engineering and the John Glenn College of Public Affairs, but all of my degrees are in astrophysics. I spent 17 years of my 35-year career at Marshall Space Flight Center in Huntsville, and my favorite Star Trek character, it might be Ricardo Montalban playing Khan in Star Trek II, The Wrath of Khan, or of course Spock is always great.
Absolutely. And in fact, we have a Khan costume entry for our costume contest, which I was very excited to see. Thank you so much. Next up, we have Jordan Moore.
Hi, I'm Jordan Moore. I'm a biomedical engineering graduate student. So I focus mostly on the technology side of medicine and how we can develop things to help with healing and wound regeneration. I'm a bit younger, so I don't really know the older Star Trek series. So I'm gonna pick a character from the recent movies. Little alien guy, Keenser, that follows Scotty around. It's probably my favorite character.
Awesome. Thank you so much, Jordan. Next, we have Don Stevens.
Hi, yes, I'm Don Stevens. I'm director of Perkins Observatory. I also do some astrophysics research, working in stellar physics and stellar structure, things of that nature. I also do a lot of public outreach work, hosting currently virtual public programs most Friday nights, either with virtual telescope observing through our big telescope up at Perkins, or planetarium shows, things of that nature.
Amazing. Thank you so much. And last but certainly not least, we have Owen Meal.
Hello, I'm Owen Meal. I just graduated in August. I studied anti-counterfeiting in the Ag Engineering department. I wrote my thesis about using holograms on a specific area of anti-counterfeiting. As for how holograms relate to Star Trek, I kind of classify holograms along with Chrome as the thing you think of when you think of the future. So Star Trek is very futuristic. And my favorite character, I think, has to be Picard.
Fantastic. Thank you. So what we're going to do now is I'm going to go into some of the questions I have for our panelists, but at any time, if you have a question, please use the Q&A to type it in there, and we'll go to audience questions throughout, interspersed throughout the call. If you prefer to use the raise hand icon, as some of our guests did earlier, you can also do that, and you can be unmuted and ask your question that way. So I'm going to start things off in the aerospace realm with Dr. Horak. So one of the questions I have for you is about propulsion technology in Star Trek. We see these systems like ion propulsion and impulse engines, which use fusion reactions to propel a spacecraft. Are these technologies feasible in real life? And what technologies do we currently use to propel our real life spacecraft?
I love it when we use the word feasible, because it's probably the most interesting word in any proposal that you'll ever read to NASA. This is feasible with an infinite amount of time or an infinite amount of money. I guess it is. Much of what you see occurring in Star Trek requires a leap of faith in terms of propulsion, because there's no way we're going to go gallivanting around the galaxy and visit planets around Rigel, for example, with the systems we use today. We primarily use chemical propulsion. We generally combust a fuel and an oxidizer in a chamber. It creates a hot gas, and we run that gas through a nozzle to create thrust. It's just Newton's every action equal and opposite reaction. You shoot hot gas out the back and the rocket goes the other way. But to get around that, and so that, you know, Kirk and Picard and everyone else and Janeway could gallivant around the galaxy, they invented warp drive, and we're not there yet. We're a long way from even, in my view, understanding sort of the basic physics behind how that might work, and then how you would instantiate that physics in hardware to make a thruster is even more out there. But it's necessary to move through, and in a sense, nothing can travel faster than the speed of light. So it's not as if you can propagate the spaceship through a volume of space at something faster than the speed of light. So you get around that problem by actually doing something to the space-time continuum itself that allows you to sort of show up in a different coordinate, and the net effect is that you have this warp drive.
Right.
What else did you want to ask? I lots of time, but I want to keep my answers brief.
Well, I'd like to maybe move from the propulsion to the spacecrafts themselves, because we see these really large, sleek spacecrafts like where me and Jennifer are currently standing on the Enterprise, right? And it seems very different than what we have in real life. So could you talk to us a little bit about what determines this design of the spacecraft, and whether or not our future spacecraft could look anything like what is depicted within the universe of Star Trek?
Well, the spacecraft design in Star Trek is designed to please the aesthetic eye of the viewer. You don't need aerodynamics. I mean, the ugliest spacecraft ever built is the lunar module, and it's not aerodynamic at all. Well, you don't need it because there's no air, so there's no lift, there's no drag. You can have all kinds of protuberances sticking out, and you just design it to do what it needs to do from a functional perspective, and not necessarily an aesthetic perspective, although when I see it floating in space, it is pretty cool. The original Star Trek Enterprise is kind of interesting because it's a flying saucer with some propulsion elements on it. So it sort of has to look sort of between futuristic airplane and flying saucer, but there's no real reason why you would do that. And in fact, I think you might make it a sphere, because you're going to want to encapsulate the greatest amount of volume with the minimum amount of material to enclose the volume. And so a sphere might actually be the most efficient thing to build, just because you get the most sort of bang for the buck, the greatest volume inside with the minimum amount of material.
Amazing. Thank you so much. And one more question for you before I move on to our next panelist. You mentioned your background in space policy. And so I'm wondering if you can tell us about how the space policies of the real life world today compare to what we see in the Star Trek universe. So for example, do you think something like this governing body of the Federation would ever be formed in the future?
Well, that's a pretty speculative question. I actually think, and we'll talk about this later in some of the other questions, but one of the most compelling things about Star Trek was not necessarily the technology. Clearly the characters and their interplay was interesting, but it is this vision of the future of humankind and of sentient living beings in the galaxy. I'll throw the Klingons and the Vulcans and everyone else in there as well. It's a very optimistic view, and I think a hopeful view. Not without its problems. I think we can take inspiration from that. And we do see in many places today our own human exploration of space between countries, serving as what I'll call a very fragile bridge between nations, communities, cultures, beliefs. We have our serious challenges, for example, on the ground between the United States and Russia. And yet, in a couple of days, we will go through the 20-year mark of continuously occupying the space station with human beings from the United States and Russia, started as the Soviet Union. So Star Trek offers a very, in my view, compelling, optimistic, and hopeful view of how we might use space to achieve greater collective outcomes, get along better, not only in space, where you have a crew of Pavel Chekhov running the ship, but also here on Earth, where most of us are going to be.
Amazing. Thank you so much. Next, I'd like to ask a few questions to Jordan, our biomedical panelist, about the medicine portrayal in Star Trek. So we see these medical tricorders used, being capable of quickly scanning a patient, and we get this instant diagnosis of their ailments. Do you think we could ever develop such a technology in real life? And what is the most similar thing to that we have at the moment?
I think that's a great question. I do think there's, I don't want to blame the physicists for this, but a lot of the limitations that we have are how do we incorporate all the physics together? Because we have devices like MRIs that use magnets to, they're really good at imaging soft tissues. They're not very good with bones, whereas X-rays and DEXA scans, things that use radiation, are really good at seeing the hard tissues. And so the question would be, can we develop something that really combines all these technologies into one, so that we can really just wave this over a person and see everything? And so that's really where the limitation is because with the MRI, we're looking at the alignment of photons, or protons, sorry, and how we can change that field really quickly and see something. And that's something I don't know exactly where we stand trying to combine that with doing X-rays and radiation at the same time. But I think that's the main limiting factor, is also MRIs are huge systems. How do we make these much smaller so that it's something that could be handheld, like an ultrasound? Again, these are all very different technologies that we have to put into one system. So I think it's ever possible. I would say yes. Similar to how we said earlier, like nothing is impossible if like we have enough time to develop that. And also we're constantly making things much smaller.
Right. So looking from the diagnosis tools to the actual healing technologies, we also see, right, this incredibly advanced portrayal where we can just shine a healing light on injuries and they're instantly healing. It's incredible and, amazing. So I'm wondering, can you tell us about, the current state of regenerative medicine and medical technologies that exist in real life? And, similarly, do you think we could ever be in a place where we have, anything that can heal someone with such great speed?
So I think with the healing process, it's a bit more complicated because you constantly have all your cells doing like individual jobs, and they all come in at different times. So when you get an injury, you have a lot of you get an immune cell activation because it gets inflamed and knows it's hurt. And those are very different cells than you get when the actual healing process occurs. And so currently it's obviously days to months, that period of time. The healing ray, if we extend that concept to what we have now and using like a laser for something, we're really good at using lasers to do like ablations and cut out things that aren't supposed to be there. And actually, in some of those cases, we can view that as a healing process, especially with cancers, and we're ablating tumors, or cases where some people have tremors in their extremities. We can use those in the brain and actually silence certain parts so that their limbs quit shaking. But I think as far as the healing process, the body itself is actually very good at taking care of it and recovering on its own. that a lot of our interventions are just basically augmenting that process. So I don't think the healing rate itself is like the best alternative. It's more like we still need to let the body do its own thing.
Right. That makes a lot of sense. Thank you. And I see we have a few questions coming in from our audience for you. So I'll go to one from Lisa, who asks you, regarding AI and 3D printing aboard the International Space Station for biotechnology, what are your thoughts on futuristic measures in microgravity with stem cell studies? Wow, good question.
So honestly, in my lab, we don't like to use stem cells very much. And it's not that there's anything like, it's not like a moral issue for us. It's more of an ability to control them, because stem cells are what we all start out with, and the body has to develop from somewhere. And stem cells have capability of becoming any cell type and complementing any organ system. And so the danger with stem cells is if you don't drive them down the right path, they can go into, they can go off and cause tumorigenesis, or they can cause like the growth of an organ that shouldn't be where it is. Mm-hmm. So I think a lot of the medicine like we focus on is actually using small particles like extracellular vesicles, which these are on the scale of below 200 nanometers. And these we can actually couple with different genes or different cargos to make the cells become what we want, or reach systems that are generally unreachable, like the brain and the spinal cord. So I think with a lot of the 3D printing, most of these things would be like for scaffolds and things that we could put into the body in place of injuries. Same with, we would want to combine these with the cells so that it's a system that mimics or is biomimetic, what we normally refer to. So it very much mimics the native environment. So I think that would be where we're trying to progress medicine currently.
Amazing. And we do have a lot more questions for you, but I'll just pick one more here before we move on, and we'll try to get back to the others once we get to all the panelists. But from David, he's asking, the original series introduced the concept of these medical scanner beds. How close are we to having technology like that in real life?
So I would say the closest to like the scanner bed again would be like the MRI or our DEXA scan machines, which you just lay down and something scans over top of you. Again, the question is, are we able to put all the different modalities or technologies into one system? So can we look at your soft tissue and hard tissues at the same time? So I think if it was a system like a bed, which isn't as miniature as the wand that we discussed earlier, that is a lot more feasible than something that we just wave over a person.
Right. Thank you. Thank you so much. Awesome. So next I'm going to go to holography because I think a lot of us here really want to talk about that holodeck with Owen. So Owen, to start us off, yeah, I mean, as a holography specialist, which I think is something that not a lot of people get to say, what is your take on this seemingly magical holodeck that we see in Star Trek? Could anything like that ever really exist? And if so, how would it be different than the way it is portrayed within the show?
Good question. I thought, first of all, I'm flattered to be called a holography specialist. Thank you. I think the holodeck is something really interesting with a lot of virtual reality stuff that's going on these days. I think it's something we're moving to, but I don't know that technically there will be holograms used in it. Holograms traditionally are like an analog recording. They're actually made on just pieces of black and white photographic film, but they're made with two different laser beams that interfere with each other in the surface of the film. And so you can, for instance, record images of, this is a hologram I made of tools. You can see needle nose pliers. And you can just record holograms just of light that intersected on the film. So I'm not sure that the holodeck would use holograms, but us in holography are flattered that the holo term is catching on, if not the hologram.
So I think one of the things that seems to me the most far-fetched about how they show it is it's not just these images, but it's things that they're touching and feeling, right? Like you can pick things up within, the holodeck. So, I mean, does something like that ever seem like it could be a possibility in real life, in your opinion?
So there's a lot of different ways that people are researching and trying to get something like that. I've seen like a TV screen that's mounted on a set of like that has motors behind it and has like springs, so it could show a ball coming at you, and then you could touch the screen, and the screen would react to your touch with this as if the ball had mass. And then with virtual reality, the imagery part is almost already here. It's just a matter of the resolution, really. But I agree that the feeling is the hard part. And there's ways, there's research being done about sending out sound waves so that as you're moving your hand through the air, you could bounce against, or you could have, I guess, pressure bouncing against your hand.
Amazing.
Yeah.
That's really fascinating. Is that something that you think would be integrated with, public access VR technology in the future?
I could see it, yeah. Far enough in the future, like everything else.
And so one more question for you. In the original series, one of the interesting things that was pointed out to me was that virtual reality was outlawed for being highly addictive and dangerous. And then we get to Next Generation and all of a sudden it's all over, right, with the holodeck. So as VR technology continues to advance and become more modern place today, do you think this could ever be a real life concern, in our actual world?
I would not put it past a lot of people to want to ban it and outlaw it. I hope it wouldn't happen. I could see how it could be addictive, much like, I guess, if having a little teeny screen in your pocket is as addictive as a cell phone is, having an entire world at your fingertips, that seems like it would be more addictive. I think it's a personal responsibility matter, though.
Right. Thank you. So we'll move along to our next panelist here. Jennifer Johnson, aka Counselor Dionna Troy, who, by the way, a shout out for the fantastic costume. Oh, perfect. I see your video is back on. Can you hear us all right?
We'll see how my internet connection is doing, but yes, right now I can.
Perfect. Well, first of all, I'd just like to say that I think you deserve special props for looking so good. Guys, take notes from the ladies on the call, from Princess Leia to Counselor Troy. I think the ladies are killing it here. And we have some questions for you. I see a few in the chat already. People want to know about this faster than light travel. And so I think we should start there. Obviously in Star Trek, this is a reality. And so I see a few questions in the chat asking if that could ever be something that exists in real life.
So if we go back 150 years, then nobody thought that there was a speed limit. When Newton was writing his equations down in the 17th century, he could imagine gravity. Like if the sun moved, then kind of throughout the universe, all the gravitational forces would change instantaneously. And then we had to come along with relativity. And so under the laws of relativity, the speed of light is a very strict limit. You're not going to go faster than that. You cannot accelerate, and you cannot have enough energy to accelerate any object faster than the speed of light. And that's because the principle of relativity states that the speed of light is the same for all observers. So no matter how fast you're going to measure the same speed of light. And as a result, you can never pass a light beam. You're always going to see that light beam going ahead of you. So you can never catch a beam of light, and therefore we can't go faster than light. But I set this up as saying, well, we didn't used to think there was one, and now we think that there is one. So who knows what will happen in the future with new physics. I mean, we don't know what dark matter is. We don't know what dark energy is. So I wouldn't give up all hope on that. But right now, no experimental result has ever survived people looking for loose wires and things like that to show that we can travel faster than the speed of light.
Interesting. Thank you. That's great to know. We have another question for you here. So from the 2009 Star Trek film, one plot point hinges on a supernova threatening to destroy an entire galaxy. Could a supernova in real life really destroy a galaxy? And if not, how widespread would its damage actually be?
No. So a supernova is the explosion either of a massive star at the end of its life, or if you manage to get a runaway thermonuclear reaction in the remains of a low mass star, in the remains of it we call a white dwarf, which is just very, very high density carbon and oxygen. And there's a lot of energy that comes out in them. Just 10 to the 51 ergs, which let me just tell you is a lot of energy, but it's nothing compared to that energy is nowhere near enough to affect anything kind of beyond 10, 15, 20 light years in terms of blasting out material from the shockwave and things like that. Maybe it's more like 50 light years, but it is not going to take out a whole galaxy. So there's a lot of energy that comes out, but not enough to destroy the Milky Way. Now, having said that, you wouldn't want to be super close to a supernova. So, one went off 10 light years from us. The idea is there'd be so much high energy radiation that we would lose our atmosphere and life would be very bad. So I can also say that there is no star within 10 light years of the sun that is predicted to go supernova. So we are safe. We do not have a massive star, and we do not have a white dwarf that is starting to become unstable for a thermonuclear reaction. So I am grateful for that.
Thank you. Thank you for that reassurance. Another kind of sci-fi twist on an astronomy topic that we see in Star Trek is this idea that black holes could somehow be capable of time travel. That's something that gets explored. So first of all, what is a black hole? And could that ever function, as a quote unquote time machine in real life?
I am not a black hole or special and general relativity expert. So let me just summarize a few things that I do know. First of all, a black hole is a very, 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 very dense object whose gravitational pull is so strong that not even light can escape. And that's where the black part of the black hole comes from. We think without a doubt that these things exist. We have, the most spectacular image is the one in the center of a nearby galaxy where we see light being bent around the black hole, exactly as we would expect from gravity bending light. And as things cross the event horizon where there's the point of no return, we think that is a real physical thing that can happen, that material will fall in past the event horizon and be lost to the universe, except as it emerges as Hawking radiation. So we think that that's going on. What we do not know at the present time is what happens at the very, 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 very densest part. So if we think about this without quantum mechanics, we say, oh, it can just go to a point of infinite density. Quantum mechanics does not do infinite densities. And so at the very, very, very tiniest levels, we need a theory of quantum gravity that says how gravitational fields are on kind of like the atomic and subatomic scale. And right now we don't have that theory. So the idea would be that there would be something very interesting in the physics that happens there that would let interesting things happen to space-time and maybe allow time travel. So there are many reasons to be excited about a theory of quantum gravity. And for me, I will definitely say that the idea for time travel or, the idea of wormholes. And so even if we can't travel faster than the speed of light, we can kind of do shortcuts across the galaxy. I would really like those things to be true.
And I'm glad you mentioned wormholes because we just got a question on that. So I'll ask this one and then we'll move to Dawn here. But David asks, so along this idea of space travel, we do see wormholes in Star Trek and they, show rapidly traveling through space. So do wormholes really exist? Or could one be artificially created to allow this type of rapid space travel?
Right. So one of the things I really liked about Voyager, Star Trek Voyager, is that it didn't shrink the galaxy down to infinitely small sizes. I mean, people in Star Trek, they go faster than the speed of light. They get between stars pretty quickly, but our galaxy is actually quite large, 30,000 light years. And so you could imagine that if you got cast into the Delta Quadrant like Voyager did, that it would actually take you a long time to get back. So we can't and they never go visit another galaxy. So, there is some bounds to how fast the Star Trek universe is. In terms of wormholes, they are a solution to the equations of general relativity. So theoretically, we're all good. However, Kip Thorne, I was reading some of his insights into wormholes, and it is hard to imagine how. So theoretically, you can write it down, but theoretically, they also disappear really, really fast with the slightest amount of energy. But maybe we don't know anything about what kinds of matter and energy are out there. And so maybe there is a way to hold one open and actually send spacecraft through. So I think maybe feeling the Kip Thorne zeitgeist, I would say that wormholes are more likely to get us across the galaxy than black holes, than faster than light travel.
Right. That's really helpful insight. And I think something that really struck me from last week's panel, for those of you who weren't here, did a Star Trek discussion, and astronomer Dr. Barbara Ryden mentioned that, even if wormholes do exist and we can go through them, there's no guarantee that it's going to be a shortcut. It could be a long cut where it makes something take much longer to go through, which I thought was a really interesting point, that it doesn't necessarily mean you're saving time. So thank you so much, Dr. Johnson. So next up, we're going to go to Dawn Stevens. And Dawn, I'd love to talk with you for a few minutes kind of about the cultural implications surrounding the show, because I think that's a really important context for the series. So something that was so revolutionary about Star Trek was, its diverse cast, showing one of the first interracial kisses ever shown on television, having a Russian character, Chekhov, in the middle of the Cold War when the show was first airing. So how does this global environment that Star Trek was released in impact the show's messages and plot lines?
Well, it comes down to what Roddenberry, who created Star Trek, envisioned. And he wanted it to not just be a TV show to entertain folks for an hour, every week. He wanted it to be a vehicle to message and promote positive messages of inclusion, diversity, growth and change, and take critical looks at aspects of our own culture and of events of the time when the show was on. This includes not just the original series back in the 60s, which, you had the civil rights movement going on, you had the Vietnam War, a lot of things were going on in the world at that time, not just the Cold War. There were hot wars going on as well. And later in the 80s, when Star Trek The Next Generation was on as well, it also was a vehicle to address many aspects of culture and cultural stereotypes and how different cultures interact and integration and things of that nature.
Thank you so much. And I see we have a question here from Chloe, and I'm going to toss this one to you. So she's asking, kind of similar to the black hole discussion we were having with Jennifer, do you think a black hole could ever affect our solar system, such as a gravity pull? So, and then she asks follow-up, could a black hole ever eat the sun in our solar system? Is that something we need to worry about, or can we put Chloe's mind at ease?
Well, I think we put her mind at ease because, for at least the last 400 years since we've had telescopes, we've done significant surveys of space, particularly the space around our solar system. We can readily observe, about 10% of our galaxy quite easily from Earth here. And the closest black hole that we know of is 3,000 light years away. So we don't have to worry anytime soon about any black holes or anything. Given that, if some reason we missed one, there was a black hole nearby. Black holes, although they are gravity well vacuum cleaning funnels of doom, you have to actually be pretty close to one to be affected. Usually within a given mass of black hole, you have to be within about 2.5 times its radius, the radius of its event horizon, to be strongly affected by its gravitational field. So that means that it would have to be, within the orbit of the moon to even begin to affect the Earth and Moon system. And, it would have to be, well within the orbit of Mercury to start doing anything in particular to the sun as well. So, the Hollywood interpretation of black holes tend to be, these things just suck everything in around them, but they actually just pretty much behave gravitationally like everything else. It's just they have a lot more gravity really close to them. So, you don't have to worry about any black holes or anything like that.
And one follow-up black hole question we just received from an attendee who wants to know, what if planet 9X could be a small black hole? Is that a possibility?
Well, I mean, again, it could be a possibility, but there are certain things about the behavior of black holes that we have pretty good understanding of through both observation and theory and computer simulations and things like that. Even a very small black hole, on the order of a planetary mass black hole, would leave very obvious tell signs of its presence out there in the outer solar system. They almost always will have some kind of accretion disk, which is the debris disk of stuff that they're just pulling in around them. And they will strongly bend light. And that's talking about earlier with the exoplanets, gravitational lensing, black holes even more extremely gravitationally lens light. So they would announce their presence that way as well.
Thank you. Fascinating. So we have quite a few questions that are just for the general panel here. So I'm going to dedicate the next 20 minutes to questions for everyone from our audience, as well as some of the specific ones I have here in the Q&A. I'd like to start with a really thoughtful question from Priscilla, who asks, can anyone identify any type of technology that was, perhaps inspired by Star Trek, or anything that exists today that, was first, portrayed before it really existed on the show? So I'm going to open that up to the floor for anyone to respond to.
I'm probably demonstrating right here, holding up the most obvious and significant contribution that can be argued that Star Trek made towards technology, and that, of course, is cell phone technology, based on this guy here, one of my props that I have from the original series, and of course is the Communicator, and it directly inspired a lot of development of wireless technology, which of course led to cell phones, which then led to smartphones, which in a sense, this is actually a merger of both this and this, the tricorder, which was mentioned or asked about earlier. In fact, my cell phone, I recently bought a little plug-in device that turns my cell phone into a Geiger counter. And so, it literally can function both as a communications device, a tricorder, a computer. This thing, the computer in this is hundreds of times more powerful than the computer that was aboard the lunar module that was mentioned earlier. So, this is probably it right here is the best example.
Amazing. Thank you. That's a great answer. Another really fascinating question that I see at least 3 times here. People want to talk about that teleportation. That's something that's a big part of Star Trek. And so numerous audience members are asking, could teleportation of any kind ever be possible in real life? And what would it take for Scotty to beam you up to move people from one place to another? So That's an open question for any of our panelists.
Who wants to be Debbie Downer? Well, I think that the physical, quantum mechanical, and just sort of mass energy transfer problem of taking a living human being from a teleportation deck on an orbiting spacecraft and setting them down on the surface of a planet intact with all of their memories intact and all of their organs in the right place, and having them essentially be the same person they were when they were beamed off the Enterprise is just phenomenally complicated. I can't even begin to describe in my own words how complicated I think that would be. We are just now, I think, in the realm of quantum mechanics, beginning to understand a little bit more about entanglement and what Einstein referred to as spooky action at a distance in the Einstein-Podolsky-Rosen experiment about entangled states. You have to understand that enormously well in real time for every subatomic particle in your body, and that just to me seems to be a beautiful fantasy, something that really helps save a lot of film when you would be using a shuttlecraft to go back and forth, right? I mean, it's safe. It was for dramatic effect. But I don't think it's something we're going to see. Maybe someone is more expert than I am, but I don't see it.
They have the Heisenberg compensators. You should have to invent those.
Yeah,
I think it's all.
I like the fact that they're that's something actually, Dr. Johnson, Jennifer, it's a really good point. Is that Star Trek especially has tried very hard to, even though you have to suspend your disbelief, they give you help, right? Well, there's a Heisenberg compensator. Well, therefore it must be something, they know something about it, right?
Right.
That makes it really attractive, and I think fun to think about, but I don't know that it makes it any closer to hardware.
Well, I mean, and I've seen recent studies done. How much computer space would you need in order to, store a person's information, their quantum states of every particle in their body, in order to reassemble them? You would need a computer about the size of Earth to be able to store that amount of information.
That is not very promising, but very good to know. Thank you. So we have another question here that I like a lot. In Next Generation, Dionna mentions that Geordi is a character who is blind, and he wears special glasses that lets him see in various wavelengths. Is something like that on the horizon nowadays? I think this comes from a lot of different angles, but maybe we'd start on the medical side. Jordan, can you respond to that sort of from the medical background that you're joining us from?
So I think it depends a lot on like the connections between the brain and the eyes, obviously, because generally when people are blind, you have damage to the rods and the cones, and then the light's not reaching the eye properly. And so I think if you're like totally blind, like there's no way, like even though I don't think you're going to be able to see any of the wavelengths anyways, because when we talk about like different wavelengths, generally women can actually see a broader range of colors than men. And there's something microscopy is when we get over generally like 650 or farther in the wavelength, men cannot generally pick up that signal, but some women can. So when we're talking about seeing different wavelengths, it still depends on where we're breaking that down into. And then also, are we able to focus and actually turn that into a real image?
That is absolutely fascinating. Thank you. Do any other panelists have thoughts on that you'd like to share?
I know they're making progress on artificial eyes, but it's still really limited and only in its infancy as far as the technology goes. And the main complication is interfacing the technology with human nerves and being able to transfer what data is received through essentially it's like a CCD camera using telescopes, or even the ones on your phone. So it's only, a limited number of pixels even that are visible to the technology right now. So, yeah.
Great to know. Thank you so much. We have a couple questions going back to the time travel concept. Judson mentions that one of his favorite Next Generation episodes involves a time loop where the ship keeps reliving the same day over and over again until they break out somehow in a Groundhog's Day scenario. Is this remotely possible in real life?
In certain classes, yes, I've experienced that.
Right. That's very fair.
Well, from a relativity point of view, time travel, it's one of those things that captures a lot of people's imagination. And time travel is possible, but due to relativity, it's limited in one direction. That's to the future. And as whether or not you could loop back. Again, it was I believe Jennifer mentioned some of Kip Thorne's work where he talked about creating artificial wormholes as a method for time travel, but then you could only travel back to the moment you created the wormhole would be the furthest back you could go. And so it's probably a good thing that the universe only allows time travel in one direction. Otherwise, your history books would be no good 5 minutes after they're published, because people would be constantly going back and changing things. And then of course, there's a whole grandfather paradox thing as well. So it's probably a good thing the universe, again, limits us to just going in one direction.
Right. Thank you. We have a medical question here from Jordan. Lisa shares that Dr. Spock and Star Trek always have the special touch for healing in space. Physiology and psychology are heavily being studied for the Human Research Program and the Artemis program for travel to Moon and Mars. What are your thoughts on the process of hypothermia in transporting humans to Mars for these long-distance space travel stints?
I think that's a great question. I haven't really considered long distance travel. It's not something, I look at a much smaller scale. I don't really think space-wise generally. But I think, especially like as you mentioned, physiology and psychology, those are a lot of things on generally how's the mental state going to be when you're, we can look at our COVID situation, when you're isolated for long periods of time. How are you going to behave when you end up somewhere? I think we've made a lot of progress with especially physiology and how we keep people physically fit in a manner, and designing like their workout systems in the space station when they're in those low gravity areas. But I think those people generally also have target deadlines and multiple ways to communicate, so their mental states hold up a lot better. But as far as like the hypothermia and things along those lines, I can't really address that, as I haven't really thought about that or can wrap my head around those concepts right now.
Right. Thank you.
And I think one of the things that we're going to have to do, and let's be mindful that what we're talking about in the real world about a long trip is 150 million miles or so to get to Mars. It's not 32 light years or whatever it takes to get to Rigel 7. For our own local trips, we're going to have to improve our propulsion systems. We're going to have higher thrust, higher specific impulse. In my view, probably nuclear thermal propulsion to cut the trip time to Mars by a factor 3 or so that people are not locked in a can with each other for a long period of time for their mental well-being, as well as to protect against potential radiation damage and other kinds of things. So we're just going to have to make the trip faster rather than perhaps try to freeze people or put them in suspended animation.
Thank you. And we actually have a really interesting comment from an ICU nurse in the chat who says, having seen too many patients in an irreversible coma, the concept of a cortical stimulator that can reactivate a brain is incredibly interesting. In your opinion, Jordan, how likely do you think we are to ever seeing something like this? Andrew goes on to have some really interesting input on hyperthermia for anyone else who wants to look at that in the Q&A. So the question is regard to the idea of being able to basically stimulate the brain and whether or not that seems feasible to you.
So I think stimulating the brain is a very interesting concept because, again, we're thinking about these millions or billions of connections between neurons and the ideal place that they're actually supposed to be. And so I think the main thing is figuring out exactly when we would need to re-stimulate certain parts. Like that's the first question, is identifying what part needs to start first. And again, that's going to take a lot of time to study beforehand. But we are able to stimulate, we are able to find parts that are stimulated, especially like for the heart, for the lungs and those things. So the concept is possible. I don't think we can always localize that. And so that's the limit of technology right now, is how do we localize the stimulation to a specific point without overstimulating other areas.
Thank you. And then one other question related to medicine here that I think is really interesting. Is it possible for a human to be exposed to massive radiation like Spock was and live any length of time like he did? Of course, he did have green blood. And you know, a famous scene, he's exposed to radiation and continues to live and doesn't just die instantly in this extreme radiation environment, you know, right next to one of the power cores. So Gail is wondering if anything like that could be possible for a human.
I think history would tell us it is possible in some levels. Obviously not to the same level as Spock, but I mean, we have nuclear bombs that we dropped in World War II. We had what was the nuclear reactor that blew up in Europe?
Chernobyl?
Yes. And so there's obviously going to be dramatic deficits, and there's going to be a ton of death that occurs with it. But there are people that live for periods of time, and obviously their lives are generally cut short, but there are ways that in some cases we can overcome radiation poisoning, though it's still going to be very limited because those levels were never meant to be in the body and the cells. It's kind of like UV radiation to a person. It damages your cells. It's just toxic. But there are ways that we can limit the effects.
Yeah, there's a couple of incidents from the Manhattan Project that not only in the last few decades have been declassified, some incidents where scientists died working on the project. One incident involved they were working with one of the plutonium cores in a lab and accidentally dropped half a beryllium sphere on top of the plutonium core. And the guy standing right there received a lethal dose and was dead within days, but there were scientists in the same room, mere feet away, who managed to survive with very little ill effects. So it kind of depends on the circumstances of, you know, the exposure and things of that nature.
Thank you. We are unfortunately very close to the end of our time here, so I'm going to take one final question, which asks about artificial gravity, which is obviously something we see in Star Trek. Does anyone here think that artificial gravity could ever exist in real life?
I do think that as the questioner pointed out, if you rotate your spacecraft, you can get a nice acceleration, and general relativity says gravity and acceleration should feel very much the same in small amounts of space-time. And so kudos to Babylon 5 for that. Yeah, and we don't have to be rotating too fast. I mean, pilots regularly pull, you know, when the vomit comet, they pull 1.8 Gs, so almost twice what we feel on Earth. So we can already get those kinds of accelerations. We don't, the kinds of accelerations here on Earth. So I think it's entirely possible. I think the power demands and the construction demands are something to keep in mind. But that is something that, if we needed to build something that accelerated at 9.8 meters per second in space, or the human race would die. I think we could do that. Transporter technology, no. Faster than light, no. But getting something that will accelerate that constantly, I think we can do that.
Well, that's exciting to end on a note of something that seems really, I know I use this word in the beginning, feasible, but realistic and feasible, maybe in the near future. So with that, we are just at 9 o'clock here. So I want to thank our audience for all their amazing questions. If you have questions that did not get answered, I encourage you to join us next month. We will be having an interstellar panel. And although it's a different topic, many of these questions here I see on black holes, time travel, we can definitely tackle next month. Typically, we meet the last Wednesday of the month, but due to the Thanksgiving holiday, next month will actually be 1 week earlier. So the event will be on November 18th from 8 to 9 p.m. So I do encourage you all to join us back at that time. And with that, I would like to thank our amazing panelists for sharing their time and expertise with us today. And to remind you that you can still join our costume contest and enter to win one of our free telescopes or our Science of Star Trek novel. So be sure to post your photos to the Ohio State Astronomy Department Facebook page by midnight on Halloween to enter. So with that, thank you all so much for joining us this evening. And thank you to our interpreters and captioners for providing our accessibility services. It has been a true pleasure. Live long and prosper. I wish I could end all of my meetings that way. Have a great night, everybody.